in the system. Okay, thank you.
Yeah, thank you very much. We can answer it. Okay,
Yeah, yeah.
very much.
Okay, we come to the second keynote speaker. Dr. Ahmad Dabwan is a senior lecturer from Faculty of Engineering Technology, University College Tati, Malaysia. So,
Yeah, I am there here.
little bit about his. Yeah, okay. You already online. Yeah, thank you.
Yeah.
So I just introduce a little bit about you,
Yeah.
Doctor. So Dr. Ahmed obtained his bachelor degree chemical engineering from King Saud University, Riyadh, Saudi Arabia, and master and PhD from Graduate School of Engineering, Mia University of Japan. So without further ado, let's invite Dr. Ahmed to present his keynote. Please, sir.
Okay, assalamu alaikum wa rahmatullahi wa barakatuh. Thank you very much, Mr. Saiden, for the nice intro. Before I start my talk, I like to thank all people who were behind this seminar. Most of them work very hard, day and night, and this seminar became real, alhamdulillah. Yesterday, there was a very good debate about, do Malaysia need rainwater for drinking or for other utilities? There are many thinkings. I respect all people and their thinkings also. But in my point of view, drinking water is not a big issue for Malaysia. The other things for utilities is the issue, especially in area like Selangor, where they are facing difficulty sometimes. So based on that, I changed my topic a little bit, not the contaminants and treatment methods. I add engineering prospect. I want to add some slides about this issue. First of all, if you know, I give you background, maybe Miss Sophia will give you more details about rainwater in every state after this lecture, inshallah. But for information, this is in Malaysia, rainfall is about 1,000 billion meter cubic meter. 36 of this evaporated, go back to the, to the sky and go to another places as rain or whatever. Runoff is 57, and this goes with sediments and mud to the river and also to the seas, meaning that also troubles of becoming another issue. Number 3 is groundwater discharge, which is about 7%. Only 4% is being used in Malaysia. So meaning that 96% of this is not utilized. And this is actually data from Dr. Khazrul. Thank you very much for this information. I teach my students also this subject, so it's very, very interesting. Merits for utilizing rainwater. I think yesterday and today also from Nahrim, also Mr. Zaki, he did also very good. He explained on the, but I will focus about two things. About doesn't depend on the terrain or geology or infra. It means that if you have a house, then you can build your tank. Tada masala. You don't have to worry about the place. This is very, very good. This is good, one of the benefits. Another thing is water can be stored beneath or close from the houses. And I will talk about the new building. This is for all building, maybe they can build the tank outside, but from the beginning, I show also something about the cost. Of course, the merits can be used for agricultural, can be used replacement of the underground water for industrial purposes, can be used to solve problem in scarcity in urban areas like Selangor, so on and so forth. Okay. I made special calculation how much water needed for our food drinks. Not calculation. This is from Google, and I found here. You know, we are eating dagin. We like all of us. So if we want to produce 1 kg of beef, we need about 15,000 liter of water. So huge amount used here. In Malaysia also, nasi ayam or ayam chicken, they are eating too much. And for this to produce one small chicken, maybe 1 kg or 2 kg, if 2 kg, you need 8,000 liter or 8 cubic meter. For sayur, for cereal, for fruits, for vegetable, less amount, but still consider big amount than what we need for drinking and for coffee and others. This slide show you in daily consumption at homes, how much we are using. So if you see here, for shower, we are using 41%. If you add wudu and this wing for us in Malaysia, and so we need maybe more than 40. This is daily consumption. This one, if you are second one for toilet, also we are using about 30%. Then we go to cleaning, laundry, we use about 12%. So meaning that if you have 100 liters here, you need only one liter for coffee and makan, maybe from 1 to 3 liters a day for each one. But huge amount will be utilized in other areas. This, I think I need to skip this slide because history of rainwater harvesting is very long, not new. But I will show you something about in Terengganu. I made a small or special calculation or easy calculation. The liter of rainfall measurement, usually liter per square meter, liter per square, in traditional terms, meaning that 1 liter per meter square equal 1 millimeter. So usually what they display in the Google or in the data, 1 millimeter, 100 millimeter, this is, but the meaning is 1 liter per square meter. In Terengganu State, annual precipitation about 2,736 millimeter. This actually 2 times Tokyo. It's very big amount. And then if we calculate the whole year, it will be 2,736 liter per meter square for the whole year. Okay. So here, before this one, if you have like this one house, 20 meter and 20 meter, and you build your tank like this one down, and the area is 5 or 10 meter into 10 meter, and height is 2.5. Okay, so you will get about area 250 meter cube. What is the meaning of this? Meaning of this, you can get this amount of water, and this gives you 3 meter cube a day or 3,000 liter a day, based on that calculation for this tank. I use only half of this area with depth of 2.5, meaning that enough for family with 10 person for each day, 300 liter a day. Actually, UNDP, they give only, the request is from 550 to 100 liter a day. So this means 3 times what is recommended by UNDP. Okay. I made small calculation, estimated calculation based on the Kuala Lumpur construction cost trend. This is from 2008, 2018, and other raw materials like concrete and cement and steel and this one. I found that if you build at the beginning, because the land cost already there, and you need to add only a big hole and to put it in concrete. So about from 20 to 30K can make tank like this one. It is not, if you, for example, take a loan from the bank, maybe 300 or 400K. If you add 20K, it is not a big issue, as long as you get, you know, what you need of water for your, not for drinking. I'm not talking about drinking, because drinking, it needs special criteria, as now Mr. Zaki mentioned that there is special criteria by Ministry of Health. But for other utilization, so if the house area is 400 meter, annual is you will get this amount, meaning 4 liter filled during the whole. So that tank, if you fill it 4 times a year, it will be more than enough. But I estimate that 300 liter a day, that is too much. If we put 100 liter a day, meaning that only 1 time full or 2 times full will be more than enough for the whole year. So I think this is for new building. It is very, very useful. And I recommend also to make from concrete, because as rainwater, usually acidic rain, acidic, not alkali or not moderate. It is acidic. So it cannot, if you use stainless steel or other materials, also it can be damaged with time, but concrete will be the most suitable material. This is the calculation I made. And for people who have more money, they can, they put like solar energy. I think Prof. Marwan talked yesterday about this issue and how to make it connected. And the first, this with the solar energy. And here you can put like flush tank, because, the first flush is the most important thing. This can be also measured by turbidity meter. Turbidity, when turbidity reach to 0, then start to open the valve to go to the main tank. Before that, if there is any turbidity, that means that you flush, just flush. So it can be also automatically controlled. The quality of rainwater is directly related to the cleanness of catchment gutters and storage tank. That is very true. And this is the possible contaminants from the roof. So it is wine blown dirt. This is bacteria, E. coli, leaves, facial dropping from birds and animals, insect and contaminated litters, and also so on and so forth. You have also here some metals or heavy metals. So we did one experiment to check what is the about heavy metals related to the dust collected from the roof of that university college. I will focus about wind and heavy metals. How much here also wind, dust accumulated within 1 year in that UC campus. Okay, the area, we use different materials. We take one from fan dust. This is from Roma, from students' hostel, cellulose, aluminum foil, plastic, and we put this we make repeated sample different places to see how much dust accumulated within 1 year. Okay, this is that UC campus. I assume that the length is 600 meter and this is 400 meter. So the area is 0.24 kilometers square. And we find out here, average is 0.24. We got about 13.44 tons, 4.24. If it is this one per year, if it is 1 meter square or 1 kilometer square, you will get 56 ton per kilometer square. Okay. We compare this one with the dust coming in Kuwait average. We found it is somehow smaller, and it's very logical because Malaysia more greenery. In Kuwait, there are many sandstorm and other things like that. So here it became, it's a little bit higher, about 4 times Malaysia. We made analysis for the dust collected for chromium, copper, lead, and iron also. We found here, I show you the results here. We found here iron is about 1.4%, is very high. If we take the average here from different samples, maybe about 7.7% about. Because this is part per million. If you divide by 10,000, you will get ppm, or you will get percentage. And it is logical here, iron is very high because surrounding area, we have stainless steel factory. We have also in north, we have Kerte. We have titanium dioxide factory. We have many factories surrounding TATUC. So we found here, this is the iron. For lead also, it is somehow, this is part per million, not very high, but somehow for cellulose, for fan dust and aluminum foil, it's almost 0. Plastic foil somehow 4. So the average, if you take the average, around 3 parts per million. For copper here, if you see here, part per million, about the average will be about 3 or 2.5 parts per million. For chromium, also this used in steel industry also, we found it's a little bit high compared to the others. So the average about, if you take here, the average will be 2,000 something. So this is for heavy metals from dust collected in 30 UC campus. Of course, it's not very accurate, but this is what we can get. If we want more accurate results, then we need to do more experiment and different seasonal, because now rainy season, if you take now, maybe very clean, tada masala. But if you take during no rain, it will be somehow higher. This is special request actually from Datuk Nasser. He asked me to toxicate about membrane when we went to Nahrim last time. And inshallah, I will give a little bit. And we did some experiment about how to make ceramic membrane from raw materials available in Malaysia. It is every industry actually. This is it is very well known. Produce special type of waste, but there is no one method for all kind of waste. You cannot say all waste can be treated by this method. Tabule. Every waste you have to study what is the main components, and then based on that you decide the treatment method. In reality, there is no one like we have three different methods: physical, chemical, biological. Biological, it takes very long time. And this is, I think now they are using in palm oil industry. In chemical, sometimes very good, but sometimes produce more toxic compounds. So it is also harmful. For physical is the best, but problem also with clogging the porosity of the membrane or of the filter. So here we did one experiment about ceramic membrane. Actually, this is maybe there are two types of membrane mainly. Membrane will be polymer or from non-metal, from metal or non-metal. This usually from oxides. Usually from oxide here. This is oxide. This is the ceramic membrane, and this is from polymer. There are mainly in the market two types. And this one, I think, more durable, more reliable. So we are using ceramic membrane for our study. What we did in our study, we take different materials like kaolin. I will show you the table later. Kaolin, sand, and boric acid, all these things. And we different weights, and we make fabrication of this. And then we go for sintering, and then we go for testing. So those are the raw material we use during our study. We make batching, mixing. You see here different ratios. The total also the same to see the difference. And then we go for fabrication. We use here hydraulic compressor. Hydraulic compressor to make the mold. Inside the mold we have a mold, and we put pressure. And then finally we got after that make sintering, because this sintering product is very, very important. It will decide your porosity. If you increase the temperature, suddenly maybe make cracks. So you have to go gradually increasing the temperature till you get the suitable porous media. The shapes we got something like that. We take these samples and we go for analysis. For after analysis, we take two measurements. One is testing by UV. We check because we use dyes. We use red methyl, and blue methyl, methylene blue, methylene red. And we check also the conductivity. We take from the from the sea water, and we make dilution, and we check how much salinity removed. Here, you see here, methylene blue removal was almost 80% for sample number 3, or 75. And for methylene red removal, we got about 96 or 97, almost complete removal with sample 3. When we go to study the porosity, the membrane here, this one will be, oh, cannot see here very clear. Here, this is reverse osmosis here, okay? And here we have nanofiltration. So between nanofiltration will be sodium chloride removal. So if you have porosity smaller than nanofiltration, it can remove sodium chloride. If higher than nanofiltration, 0.008 micron, then it cannot remove. It means that it will pass. So After analysis, we got about 45 removal efficiency of sodium chloride by the ceramic membrane we fabricate in TATI UC or UC TATI. And here the conclusion, I think successful fabrication of the ceramic membrane was achieved. And then we got 76 for methylene blue, methylene red, and 45 for methylene blue, and about almost complete for red methyl, 76 for methylene blue, and 44 for sodium chloride. Okay, that is, I think, a good achievement, because you can make series treatment, so you can get less and less for sodium chloride. I want to go for also treatment by H2O2, or we call it hydrogen peroxide. That is also very, what is the mechanism? Actually, rainwater contains H2O2 in very small amount, and this is because of thunder from the, during the rain. And what is the benefit of this? If you have here catalyst, it means that you have salt in the soil and rain come to the soil, and you have sunlight coming by here from the sun. It will make something called Fenton reaction. Fenton reaction, you produce OH radical, very strong, because this is very oxidant, very strong oxidant, will produce OH radical. And this OH radical can attack persistence of herbicides in the soil. This is very complicated to degrade naturally. So with attacking by OH radical, it can reduce to something called demineralization and produce CO2 N2H2O. It means that this is normal formula of this. Normal, it's not toxic. But here you have sometimes benzyl group connected with arsenic, with zirconium, with other elements. So you can get very complicated compounds, cannot degrade, and very toxic. If goes to underground water, also very toxic and make carcinogen. So this is very somehow very useful food, very useful tools to degrade pesticide or insecticide in the soil. Advantage, contrary to other chemical substances, hydrogen peroxide does not produce any other gases. Safety depends on the applied concentration, because hydrogen only completely dissolve in water. Disadvantage, hydrogen peroxide is a powerful oxidizer. It's very, very dangerous, because if you put in unventilated room, it makes, react with other chemicals and make fire explosion. So it needs special care when storing, very, very important. It is good tool to remove also now, IR Zaki, he talked about from Nahrim, he talked about ultraviolet. It can be also used to kill bacteria, but also H2O2 can do, but needs special care. I think manufacturing, there are two, by electrolysis and by high current density to produce hydrogen peroxide. I think it is Hujan outside, Hujan harvesting, rainwater harvesting. Thank you very much for listening. Wassalamu alaikum wa rahmatullahi wa barakatuh.
Thank you very much, Dr. Ahmed, for your sharing session on the treatment process, particularly on the ceramic membrane as well as the hydrogen peroxide. I open for participants if you have any question to the speaker.
Tada, maybe okay, understand.
It's very, very clear, loud and clear.
No, I made very simple for normal people to understand. If they build their concrete tank under the ground, will not cost anything. Very small amount, but you will get the benefit all the year. That is my intention from this, lecture.
Probably a very short question from me.
Yeah.
How far you go for the ceramic membranes in terms of application and commercialization?
This is still, we need to make characterization to know the porosity, how much micro, how much nano size or micro size. This we need to make further investigation. Maybe UTHM can help us to make analysis. We don't have SIM.
Yeah,
Scan
yeah, yeah.
electron
Yeah, yeah.
microscopy. Maybe we
So,
can.
so yeah, because we have a team on developing the membrane, as particularly for ceramics from ceramic materials. So
Alhamdulillah. Maybe we
probably
can make collaboration
can,
in the
yeah,
future with them.
sure, sure.
Hmm.
All right.
Dr. Ahmad,
Yeah.
I have a question.
Yes.
Maybe it's not kind of like related to your topic today, but I just want to have
Boleh. Hmm.
regarding to what Mr. Gary Lim said yesterday.
Yeah.
He did mentions about that we use the treatment waters,
Yeah.
which cost a lot, but then we use it for our flushing. So what is your opinion? Is there any like alternative to substitute the expensive treatment waters with, something else, to reduce the cost? Because like what Mr. Gary Lim said yesterday, it was costly, and then we just use it to flushing. So what is your
Okay, very,
opinion on?
very good question. This is what I am saying, that for flush toilet, for cleaning outside your bathroom, for gardening, you don't need special care of this water. Only filter, if you make filtration, normal filter, paper, no need for ceramic. Ceramic is very, very mahal and complicated. Just filter paper will be more than enough. Because if there is also bacteria, germs, whatever, will not be affected you because you don't drink. It is just for flushing. And to bring, like yesterday debate, it was very interesting. To bring very big pipe from very far distance, it costs too much money for the sake of the houses to flush toilet. And I think it is costly. It is cost too much. For drinking only, you can make special care. For other things, of course, special care needed, but not really needed. To only filtration more than enough. Sand filter can do the job. I answered your question, Conrad?
Yes, Dr. Ahmad. Thank you so much for your
Okay,
opinion then.
thanks a lot.
Yeah, yeah, very good feedbacks and question from one also. I think I have to stop you.
No problem.
And again, I would like to thanks for your time and contribution to this seminar.
Thank you very
And
much.
probably the participant who want to contact or communicate directly to Dr. Ahmed, you can contact him directly through email,
No problem.
or you can post your email address or your contact in this session, so that
Okay,
they can
inshallah.
refer you after it.
All right.
Okay, again, thank you very much on behalf of the committee. Dr. Ahmed Dapwan, Senior Lecturer, Faculty of Engineering Technology, University College Tati. Thank you very much. Okay, we go for the next keynote speaker, Mrs. Fadila Jasmine binti Fakaruddin. Are you